there is an additional level of multi-threading. What I've just talked about is this. Consider each of these rings, circles, whatever, a thread. That's your agent, right? Has 3 publishers, 2 subscribers. So each of them runs in its own thread. Now there's a next level of multi-threading, which at this time is only available in the Java version. In the .NET, we will do that a little bit later, when exactly we're not quite sure yet, but I don't think we'll be too far off. So it's no big deal, but once it's there, it helps in some cases. The subscriber. There are bottlenecks with the subscriber. The biggest bottleneck is a subscriber receives a message. I take the event mode because that's the best place to actually observe the bottleneck. It receives an event, goes back, yeah, I've received it, and if it's only running on thread, processes that event. Once it's finished with that, it will go, give me the next one, blah blah, does the next thing. Give me the next event, blah blah, done that. Depending how long that takes, process that event. I take now a stupidly high number, really will take that long, but let's say each event that comes through takes 3 seconds to process. There's 100 messages sitting on the SIS. You do the numbers. You know how long it's going to take until it's finished. The SIS theoretically could deliver you what we found so far, about 30, maybe in a good day, 40 messages with bandwidth and all speed and all this. Could theoretically deliver you that many messages per second. But the subscriber can't process them as quickly. So we have implemented a multi-threading way with the typical producer-consumer model, which you can see here. The subscriber has actually multi-threaded consumers. That means he can, in that particular case, he'll be able to go, give me an event, gives you 3 events in the thread quickly, and then goes, gives it to the consumers, they each process. So it's 3 times faster, conceptually. Practically, there's a limit on it, because remember, it's a subscriber that will talk to a app. That app, take the database, has problems because you have database locking until one has really inserted before the actually other consumer can insert it. So they might be a little bit being locked out, wait for other things, wait for these things. When I need a test, and the SIF demo has these tests in there, so you might as well want to play a little bit with it to see where we can push it. I had one example, I took a couple hundred messages, put it up on the SIS, started to subscribe in a single process here, just have 1 consumer, so like sequential, like it was without multi-threading. See how long it takes to process them. I had a random number between 1/10 to half a second, where I just had the thread sleeping and do nothing, just to pretend it would do something. I got, as you would expect, the average takes about 2.5 tenths per second, averaged roughly there, times 100 messages, yeah, you got 30 seconds roughly until it was finished. Then I put 3 consumers in there, and the same behavior. And I got it down to about 2.5 the speed. Not 3 times exactly, because then there was a database locking and there's a bit random with the numbers, how they sleep and all this. But I ran the test several times, about 2.5 times faster than it was with a single thread. So you had the gain, I really can see that. Then I pumped it up to 5 consumers. That was it. I didn't get any further improvement to 3. It is because then they start racing for the database, or for the file in my case, and file locking and all this. They start racing for these speeds, so they had to wait until you unfinished. So when you do set that property number of threads into consumers, don't go overboard. Do some testing, right? If you don't, I put 100 consumers, I'm going to be 100 times faster. No, unlikely. But in that particular test with file, it has proven 3 is an ideal number. I really get a gain of 3 times. After that, I didn't get any further gain. So I don't know how it behaves with other systems, with databases and all this. You guys have to try that in your environment if you want to see if you're getting improvements there, but you can, to some limit. Also consider, now going back to resource management, each thread, of course, blows up, makes a bit more memory and all these bits and pieces, using all the resources on your machine. So having an agent with 20 publishers, 15 subscribers, and each of them having 100, okay, you get the point. It's getting a bit pushy. So be sensible about it. The next test I did is having actually the agent publishing the same setup, as you can see here, but publishing 100 or 200 events to 2 zones, and then subscribe on the other side is one subscriber here going to 2 zones instead of 1. And surprisingly then, even though I had 3 consumers each, suddenly I got even a higher throughput. Okay, there was double the amount of messages processed, but I got 5 to 7 times the throughput. So I'm not quite sure how that worked, but somehow it even improved it, even though they were all racing still for the same file to write to. It was quicker to go through the queues, yes, I know that, but I was surprised that it was still fast because they were still racing for the same file to write to at the end. Anyway, but it was interesting, you see 400 messages come, they came down really quickly with having these smart consumers here. The SIF demo project has that example in there. Try to play with it when you want to see how it behaves.